All right, you are welcome again. Today, I want us to take a look at this problem under exact equation made easy. Exact equation made easy. We are asked to show that this equation is exact and we are to solve it. 2xy minus tan y dx plus x squared minus x sec squared y dy is equal to 0, right? So we are asked to show that this equation is exact and we are to solve it. So what is an exact equation? A differential equation of this form: m of x comma y dx plus n of x comma y dy equal to 0. This equation of this form, which is a differential equation, is said to be an exact equation if partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Are we together? Good. Let's try it. So the part that is having dx, let's call it a letter m. The part that is having dy, let's call it a letter n. So we're going to differentiate m partially with respect to y and differentiate n partially with respect to x and see if these two partial derivatives are going to be same. Now let's go. When we differentiate m partially with respect to y, here that we have 2xy differentiating with respect to y is going to give you 2x, then minus tan y. When we differentiate it with respect to y, is going to give you sec squared y. Are we together? Yes. Then for the part of n, we have x squared minus x sec squared y. Let's differentiate it partially with respect to x. Differentiating x squared, we're going to give us 2x. Now, differentiating minus x sec squared y with respect to x, applying product rule. Differentiate x, multiply by sec squared y, plus differentiate sec squared y, multiply by x, right? So when you do so, when you differentiate x, or let's say minus x with respect to x, is going to give you minus 1 multiplied by sec squared y plus differentiate sec squared y with respect to x is going to give you 0 multiplied by minus x equal to 0, right? So here, partial derivative of n with respect to x is equal to 2x minus sec squared y. So therefore, we see that partial derivative of m with respect to y is equal to partial derivative of n with respect to x. Okay, so we say that this equation is exact. Now, the solution to the exact equation that we're looking for is integrate m with respect to x, integrate n with respect to y equal to 0. Right? Good. When you do so, we have the integral of 2xy minus tan y dx plus integral of x squared minus x sec squared y dy equal to 0. When you integrate 2xy with respect to x, we're going to have 2x squared y all over 2 minus, when you integrate tan y with respect to x, we're going to have x tan y. We have minus x tan y, right? Plus integrating n with respect to y. So when we integrate x squared with respect to y, we're going to have x squared y, right? Good. And when we integrate minus x sec squared y with respect to y, it's going to give us minus x tan y plus c equal to 0. So let's simplify. When you simplify the two integrals, we're going to have x squared y minus x tan y. That is for the first integral. Then the other integral is going to give us x squared y minus x tan y plus c equal to 0. So what do we have in common? We have x squared y and we have minus x tan y. Let's pick one of them. All right, one of them each. Now we're going to have x squared y minus x tan y plus c equal to 0 as the solution to the differential equation 2xy minus tan y dx plus x squared minus x sec squared y dy equal to 0. Hello, are we together? Yes. Let's take another problem under exact equation made easy.